Okay, last lecture we have solved simultaneous equations, right? And now we are supposed to move and do something more related to
सर
polynomial.
लास्ट क्लास यू सेड की जो लास्ट प्रॉब्लेम दिला होता तुम्ही त्याचं सोल्युशन डिस्कस करणार आहे.
हा सांगा मला प्रॉब्लेम.
सर प्रॉब्लेम असा होता की yz इक्वल टू a इंटू y प्लस z प्लस u zx इक्वल टू a इंटू z प्लस x प्लस v आणि xy इज इक्वल टू a इंटू x प्लस y प्लस v.
Okay, so let me write down that problem. I think I will have it. Yes, yz is equal to a into y plus z plus u. Okay, let us take one equation at a time, and whatever we do for this, we should do it for remaining two. So this is the first equation, and what we should do here is, let us take these two guys to LHS, or maybe what is to be done? Yz minus ay minus az is equal to u. Okay, so now suppose I am taking out y common from the first, I get z minus a, and from these two guys, if I want, from this one I want z minus a, and I have minus a here. So what damage I am doing? Yz term is achieved, minus ay is achieved, minus az
square
plus a square. So u square plus a square. This makes it y minus a.
Sir, u plus a
Sir,
square.
u plus a square.
U plus a
सर
square.
u प्लस a स्क्वायर.
U square है, u plus a square. Z minus a is equal to u plus a square. Similarly, z minus a into x minus a will be equal to v plus a square, and similarly x minus a into y minus a will be equal to w plus a square. And now I think should be doable. 1, 2 and 3. If I multiply 1 and 2 and divide by 3, I get z minus a bracket square is equal to u plus a square into v plus a square upon w plus a square root right, and therefore z is equal to this plus a. I mean, cyclically you have to write r, and that is what is your solution here. समझ गए क्या? Therefore, what is most important is this step: adding a square to both sides of equality. Fact makes the given expression LHS into factorized form. Okay, understood? And I mean, you will have a question: how do we come to know, sir, a square need to be added? I mean, it is by experience. If you solve more and more problems, you will come to know that this is the algebraic adjustment that you are required to do for getting the solution of this problem. It is as simple as that. Okay, next. Suppose I give you p of x is equal to 3x cube plus 2x square minus 3x plus 1. It's a cubic and hopefully it will not have good root. If it is having a good root, I will change some constant so that it does not have good root. Okay. So now what am I trying to tell you is, suppose p of x, if let u comma v comma w are the roots of p of x is equal to 0. Okay, so now you know lot of information about u plus v plus w. If p of x is this, you know a lot about u plus v plus w, except you know u and v and w. Right, do you agree with me? You know everything except what are the values of them. Everything means sum of the roots, product of the roots, 2 at a time, summation, etc. Everything you know. Now if I give you a question 1. Find q of x such that its roots are 1 upon u, 1 upon v, 1 upon w. Can you get me the q of x, polynomial in x, such that its roots are 1 upon u, 1 upon v, 1 upon u. Or the roots of the equation q of x is equal to 0 are 1 upon u, 1 upon v and 1 upon w. Try your level best. Okay, in this case, solving this polynomial, finding values of u, w, taking their reciprocals, and then creating a polynomial q of x may not be the good idea, because the polynomial seems to be such that it will not have good values of u, v, w. And therefore, it will be extremely difficult route to follow. Instead, there are two ways of doing it. Two ways of doing this. Let me explain the first long method of doing it. First long method of doing it is as follows. Number 1. Can we get the information about sigma 1, sigma 2, sigma 3 from the given equation p of x? Yes. U plus v plus w, which is equal to sigma 1 of the given equation, is equal to किती आहे? -2 by 3. Sigma 2 of given expression is -1 and sigma 3 of given expression is -1 upon 3. Do you recollect this? We had done this before 1 week vacation.
Yes, sir.
Okay, so let me write down what is this. uv plus vw plus wu. What is this? uvw. This is equal to this. So now what we require, let me put it in green. We require sigma 1 dash, which is 1 upon u plus 1 upon v plus 1 upon w. We require sigma 2 dash, which is 1 upon u into v plus 1 upon v into w plus 1 upon w into u. And we require sigma 3 dash, which is 1 upon u, v, w. That is product of the roots. This is sum of the roots. This is sum of the product 2 at a time. Okay. And if we get these values, sigma 1 dash, sigma 2 dash, sigma 3 dash, then q of x would look like, q of x would look like, असं दिसणार आहे q of x, x cube minus sigma 1 dash x raised to 2 plus sigma 2 dash x minus sigma 3. This is how the required polynomial will look like, provided we have these values. Now let us see if we can get these values with this information available. Okay, so if you take LCM of this, it is UVW, and what is there in the numerator? UV plus VW plus WU. So we know this quantity is minus 1, and we know this quantity, this is minus 1 by 3. That makes sigma 1 dash equal to 3. Good. How about this? This is easy. This is minus 3, reciprocal of this sigma 1. And then this is also simple, U plus V plus W divided by UVW. Is that right? Which is equal to minus 2 by 3 divided by minus 1 by 3, which is 2. Hence, the required polynomial is x cube minus 3x square plus 2x minus minus plus. That is what is q of x required. This is what going about it. One way, first method. You deal with coefficients. Information about coefficients is given. Use that information to find out information about the required coefficients. And with some algebra, you are able to do it, and hence you could locate and get this. So now, this polynomial will have roots 1 upon u, 1 upon v, 1 upon w. This polynomial will have roots u, v, w. That is how they are related. Method 2. Now, this is important, and you need to understand what is happening here, because if you understand, then you are there, and it is short method, less time consuming. So P of x is equal to 3x square plus 2x square plus 3 minus 3x plus 1, and we are saying u, v, w are roots. So in other words, what we are saying is P of u is equal to 0, which means 3u square plus 3u cube plus 2u square minus u plus 1 is equal to 0, right? So we are putting x is equal to u to get this relationship. I can put x is equal to v to get this relationship. I can put x is equal to w to get similar relationship. Okay. So if x is equal to u and u is supposed to be the root of given polynomial, what we are supposed to find out, to find polynomial whose root is q of x, whose root is 1 upon u. Okay. So 1 upon u would be actually 1 upon x, because x is equal to u. So in place, and then if I say q of x, what I will say now is, because this x will get confused with this x, we are searching polynomial q, so we will write that polynomial q in, say, y. Q of y will be equal to find q of y such that, not equal to, such that its root is 1 upon u, that means 1 upon x. So root is 1 upon, so y is equal to 1 upon u, so I call this as y, right? So if 1 upon x becomes y, therefore 1 upon u will become root of the required polynomial, whatever we will get, which is in terms of y. Therefore 1 upon x is equal to y implies x is equal to 1 upon y. Okay, so if x is equal to 1 upon y, I might as well put it in this. So it will be p of x eventually will be looking like 3 upon y square, x is equal to 1 upon y, plus 2y,
Sir,
y
it should be
plus 2 upon y square minus 1 upon y plus 1. But then this is not polynomial. Now I should say this polynomial is in terms of y. Okay, so but then this is not polynomial, but we want polynomial equation to be 0, so we may equate it to 0, and therefore what happens is if we multiply everything by y cube, LHS as well as RHS, we get 3 plus 2y minus, was this coefficient minus 1?
sir, -3.
It should be minus 3. So if I am multiplying throughout by y cube, I get 3 plus 2y minus 3y square plus y cube is equal to 0. And then this is my q of y. Q of y. This is q of y. I should not change this to y. I should keep it x only. This is p of x. But I am putting x is equal to 1 upon y. So, and then multiply everything by y cube. Hence, I get q of y, which is equal to y cube minus 3y square plus 2y plus 3, which is same as this. Questions? Have you understood this method? We are just changing the variable. Earlier variable is x, now we are making it y. And we know how y and x are related to each other. If you want the root to be reciprocal of the earlier, y and x are related to be x is equal to 1 upon y or y is equal to 1 upon x. That is how it is. Okay, so if you solve the next problem, you will come to know what transformation we are trying to discuss. Next problem, p of x. Or let me have the p of x same. Has UVW as a root, find the polynomial q of x whose roots are 2u, 2v, 2w. Problem quickly. Okay, in this case, now what is required to be done? Let us solve this problem by second method. First method is also going to be easy. Second is still easy. X is equal to u. So 2x is equal to 2u, which is equal to y. Okay. Therefore, x is equal to y upon 2. And hence, substitute 3y upon 2 bracket cube plus 2y upon 2 bracket square minus 3y upon 2 plus 1 is going to be equal to q of y. Clearing the denominator means multiplying by 8. You get 3y cube plus 4y square minus 12y Is it correct? Plus 8 is equal to q of y. That is your answer. Next question. Same. P of x is same. You are supposed to find out q of x whose roots are q of x whose roots are u plus 2, v plus 2, w plus 2. Solution. So x is equal to u, y is equal to x plus 2, u plus 2, so x plus 2 makes it x is equal to y minus 2. And therefore the required equation is, put y minus 2 wherever x is, 3 into 3 y minus 2 bracket cube plus 2 into y minus 2 bracket square minus 3 into y minus 2 plus 1 is equal to q of y. Simplify, you get 3y cube minus, what is the solution? Answer 316, na?
Yes, sir.
Yes.
Y square plus
25.
25y minus b. That is your answer. Okay, we will keep playing with them. Okay, so this problem is to be solved. Y is equal to 3x plus 1, so x is equal to y minus 1 by 3. Put it everywhere in the polynomial, make it q of y. Expand and simplify, you get y cube minus y square minus 10y plus 19 is equal to 0. Is the required polynomial whose roots are 3u plus 1, 3v plus 1 and 3w plus 1. Next problem is q of x whose roots are u plus v, v plus w, w plus u. Find q of x. Okay, let me give you a hint. Now, p of x, let me write down p of x once again because it is long back. We have written 3x square cube plus 2x square minus 3x plus 1. Okay. And it is given that this polynomial has three roots, u, v and w. And you are required to find out the polynomial whose roots are u plus v, v plus w, w plus u. So we are in trouble as far as our transformation is concerned. But are we really in trouble if we use method number 1? I think we should be able to do it. It is going to be long, but you should be able to do it. So that is one way of doing it. You find out u plus v plus w plus u, 1 dash, sigma 2 dash, sigma 3 dash, and you get the final equation. That is the foolproof method, always going to be correct. Even though it is long, it will give you correct result. And as far as transformation is concerned, what is u plus v plus w? It is minus 2 by 3. And you are supposed to find out this. Your root is u plus v. So u plus v is going to be minus 2 by 3 minus w. So You want to find out polynomial q of x whose roots are u plus v. Instead of I can say whose roots are minus 2 by 3 minus w, minus 2 by 3 minus v, and minus 2 by 3 minus u. Oh, that is correct. Therefore, y is equal to minus 2 by 3 minus x makes it x is equal to minus 2 by 3 minus y. Put it back into the original equation and you will get it. Find out. It is the same transformation which we have used earlier. But here instead of u plus v, you use one of the sigma ones which is available, minus 2 by 3. Make it minus 2 by 3 minus w. Then use this transformation. करा उत्तर काढा. Final expression, that is what is your transformation. So you q of y is going to be 3 times minus 2 by 3 minus y bracket cube plus 2 times minus 2 by 3 minus y bracket square minus 3 times minus 2 by 3 minus y plus 1 is equal to 0, and then you clear the denominator and you will get the answer. Can somebody tell me the answer? The answer is 9y cube minus 9. What are the middle terms? J
plus 12y square
plus
12y square minus 5y.
this is what is your answer. Now, as far as doing algebra and multiplication of this is cube of this, square of this, simplifying, clearing the denominator, etc., you should be doing it quickly. Let me put the last one in this series. It's this problem q of x whose roots are uv, vw, wu. Sure, do it completely. Let us solve together. Now, of course, you are so wise that the hint for this is product of the roots is known. Therefore, product of the roots, that is u into v into w, is equal to minus 1 by 3. Therefore, uv is equal to minus 1 by 3 w, right? And w was over x, so minus 1 by 3x is equal to y. Therefore, x is equal to minus 1 by 3y. If we put it 3 into minus 1 by 3y bracket cube plus 2 into minus 1 by 3y bracket square minus 3 into minus 1 by 3y plus 1 is equal to 0. So we have to multiply by 327y cube, which will give us minus 3 here, plus 27y cube will be 9y square in the numerator minus 2 minus 18 y. Is that correct? Then this is this correct? Whatever we have done, 9y 27y cube upon 9y square is 3y minus 6y. Then you are multiplying by 27y cube, so it is 9y square in the numerator plus 27y square plus 27y cube is equal to 0 makes it 9y cube plus 9y square minus 2y minus 1 is equal to 0 in the reduced form. This is what is your equation whose roots are going to be uv, vw, wu. अरे काय समजते का तुम्हाला काय चाललंय ते? Okay, now next one. Construct polynomial q of x whose roots are 3 plus u upon 2u, comma 3 plus v upon 2v, comma 3 plus w upon 2w. Do it. Most difficult in this family of the problems that we have discussed today, but we should be able to do something about it. We decided to put y is equal to 3 plus x upon 2x. If we split them, what will happen? 3 upon 2x plus 1 upon 2. Is that right? So can I say y minus half is equal to 3 upon 2x? So can I say 2y minus 1 is equal to 3 upon x? I think I should be able to say so, and therefore I should be able to say this also, x is equal to 3 upon y minus 1. Yes or no? Therefore my polynomial is going to be 3 into 3 upon 2y minus 1 bracket cube plus 2 into 3 upon 2y minus 1 bracket square minus 3 into 3 upon 2y minus 1 plus 1 is equal to 0. This is what is going to be my equation. So multiplying the entire equation by 2y minus 1 bracket cube, I get 3 into 3 into 3, 3 raised to 4, that is the first coefficient, plus 2. I am not going to make any kind of hurry, into 9 into 2 minus y, sorry, 2y minus 1, that is first power, minus 3, then into 3 into 2y minus 1 bracket square plus 2y minus 1 bracket cube is equal to 0. Is that okay? Therefore, now I think I can do it by using mind than hand. This is the most difficult stuff, so maybe I will write it here. 8y cube minus 12y square plus 6y minus 1. That is what is expansion of that. Therefore, what is the coefficient of y cube? It is 8. Plus, what is the coefficient of y square? Minus 12 from here. Y square, this is going to be 4, and now no 36, so minus 36 from here. That is going to be minus whatever. Plus, what is the coefficient of y? Plus 6 from here. Here the middle term will be y with minus 4y, and this is minus now 36, so plus 36. And what is the coefficient of y here? Now 36 again, correct? Plus constant minus 1 here. Here it will be plus 1 into minus 9, that is minus 9. Here it will be minus 18 plus 81 is equal to 0. Okay, so I have got a little space here which is sufficient. 8y cube minus 48y square plus 72 आणि 6 78y plus this is 9 plus 1 10, so 28 is to be removed from 81 minus 28 and now the 53. Is this the answer?
Yes, sir.
Yes. So that is how you need to deal with this kind of problems. Okay, so let me check if I have any more transformation of equation problem here instead. I have 12 minutes, so I should give you a simple problem. Okay, in 12 minutes what we will do is, we will take a good polynomial and cross check whether our theory is working or not. Let us cross check. That is going to be interesting. Let me create a polynomial whose roots are x minus 1. So first root is 1, second root is x plus 1 minus 1 and x minus 2. This is our p of x, whose roots are 1, minus 1 and 2. Okay, what is this cubic? X square minus 1 is to be multiplied by x minus 2, which is x cube. How many x squares? Minus 2x squares. How many x? Minus x plus 2. Okay, so if p of x is given like this, u is equal to 1, v is equal to minus 1, w is equal to 2. Okay, now when we say that the roots of the required polynomial should be 1 upon u, 1 upon v, 1 upon w. Okay, we replace x by y and therefore we get q of y as 1 upon y cube minus 2 upon y square minus 1 upon y plus 2. Simplifying is equal to 0. So multiplying throughout by y cube, we get 1 minus 2y minus y square plus 2y cube is equal to 0. Okay, so what is the reciprocal of 1? 1. So is 1 root of this? So what is 1 upon u? 1. What is 1 upon v? Minus 1. What is 1 upon w? Half. Okay, so we can see if we put y is equal to 1, this becomes 0, therefore 1 is a root. If we put y is equal to minus 1, this is minus 2, this is plus 2, 0. So these two roots are anyway there. Let us check whether half is a root or not. 1 minus 2 upon 2 minus 1 upon 4 plus if we put half minus 1 upon 4 plus 2 into 1 upon 8. Is this equal to 0? This is plus 1 by 4 plus 1 by 4 minus 0. So indeed you get these three roots by whatever transformation that we have made. Okay, let us do one more. Yes.
Sir, how did you get 1 upon y cube minus 2 upon y square minus 1 upon y plus 2 equals 0?
I am replacing now. We did that transformation. X, y is equal to 1 upon x. Therefore, x is equal to 1 upon y. So in this equation, you replace x by 1 upon y. You get this. Okay, now let us cross check. Find the polynomial whose roots are say 3u plus 1, 3v plus 1, 3w plus 1. So if 3u plus 1, 3v plus 1 and 3w plus 1, then what will be our roots? 3 plus 1, that is 4, minus 3 plus 1 is minus 2. These will be our roots. So what will be the polynomial? Our theory says y is equal to 3x plus 1. Therefore, x is equal to y minus 1 upon 3. Alright? Putting this into this polynomial, putting that in this polynomial, we get y minus 1 upon 3 bracket cube minus 2 into y minus 1 upon 3 bracket square minus y minus 1 upon 3 plus 2 is equal to 0. Multiplying everywhere by y raised to 3. So y minus 1 cube minus 6y minus 1 square minus 9y minus 1 plus 54 is equal to 0. Okay, so let us do this now. This is y cube. What will be the coefficient of y square? It will be minus 3 from here. It will be minus 6 from here. Plus, what will be coefficient of y from here? Plus 3. What will be coefficient of y? Minus 2y inside. Minus 6 plus 12. And this is minus 9y. And what will be the constant term? Minus 1 from the first bracket. Minus 6 from the second. Minus plus 9 from the third. Plus 54 from the fourth. Therefore, our equation q of y is equal to y cube minus 9y square. This is 15 minus 9. 6y. And how much is this? 10, that is 64 minus 6. Is equal to 0. Okay. And then what roots we have found out? Let us check 7. Okay. If 7 works, then everything else will. Or let us check minus 2 first. This is minus 8. Minus 2, that is 4. Now 36 minus 36. Minus 2 makes it minus 12 plus 58. चुकलं काहीतरी. Find out the mistake. There is a mistake. X is equal to y minus 1 upon 3.
Sir, 56 येते 58 नाही.
इथे का?
हो सर.
64 minus 6. This is 64, na? Minus 6.
63, and the 1 should be minus because it is the cube of minus 1.
Yes, sir.
Okay. Mistake. This should be minus. That makes it 56 here.
And it's not 64, it will be 63.
Yes. So what will be the final constant here?
56.
56. Is this 56?
Yes.
So minus 2 works. Let us check 4. 4 चौक 16 चौक 64 64 minus 16 9 144. बरोबर आहे. Then what are we trying? 4 7 चौक 24. Is it working? 8 नाही नाही हे चुकलं काहीतरी.
Sir, 56.
अरे हा
56.
this is 56. So 70. हा झालं ना.
हो सर येते.
It is working and it will work for 7 also. I am sure. So I am just not only the process that we have used, which is transformation of equation. It was correct anyway, but we have now cross-checked it by taking a numerical example and it works. That is what I wanted to bring it to your notice. Okay. So now I am going to, okay, let me stop.